Good day, everyone. Welcome to another fun episode of Valenzuela Live in Mathematics 7. I am your teacher, Eliakim Dugos from Valenzuela National High School. Before we start our today's lesson, kindly prepare your self-learning module, pen and paper as we go through our discussion. Please be reminded that you may ask your questions at the comment section below. Are you ready to join me for today's lesson? Let us start. For our lesson, we will be discussing real numbers in scientific notation and real number subsets and their orders. This will be the last lesson for the first quarter for the academic year 2021-2022. For our objectives, at the end of our discussion, you should be able to write real numbers in scientific notation and solve real-life problems involving it. Illustrate and describe the different subsets of real numbers and arrange real numbers in increasing and decreasing order on the number line. Let's have this scenario. Vivian and Grace are both grade 7 students. Science is one of their favorite subjects. Vivian wants to be a physicist, while Grace dreams to become an astronaut. During the time of enhanced community quarantine, they made some research and share knowledge. Proxima Centauri, the closest star to our own planet, is 40,208 billion, according to Vivian. Meanwhile, Grace's research is about bacteria. Bacteria generally ranges from 0.3 to 5 microns, or 0.000003 to 0.000005. Did you know that two big and two small numbers can be written in scientific notation? But what is a scientific notation? Scientific notation is a convenient way to write very large numbers or very small numbers. In scientific notation, all numbers are written in the form of a times 10 raised to n, whereas a is a decimal number greater than or equal to 1. But less than 10, and n is an integer. Take note, the value of n also indicates the place value of the decimal point. There you have it, a scientific notation form. This time, let us test your knowledge if the given numbers is in scientific notation or not. All you have to do is click like if the given example is in scientific notation and click heart if it is not in scientific notation. Let's have activity number 1 entitled Let's React. Here's the first given numbers. 2.16 times 10
raised to the fourth power.
Is it like or heart? You have 5 seconds to answer. Your timer starts now. Time's up. If you click like, then you are correct. It is a scientific notation. The value of a is greater than 1 and less than 10. And the value of n is an integer. Next is 0.16 times 10 raised to negative 4. Is it like or a heart? Your timer starts now. Time's up. It's a heart. It is not in a scientific notation because the value of a is less than 1. For the last given, 8.17 times 10 raised to 1/2. Is it like or a heart? Your timer starts now. Time's up. It's a heart. It is not a scientific notation because the value of A is less than 1, but the value of N is not an integer. But how should we write decimal notation in scientific notation? Decimal notation includes whole numbers of decimal point. But how should we write decimal notation in scientific notation? Decimal notation includes whole numbers of decimal point. Let's have example number 1. Write 54 million to scientific notation. First, is place the decimal point to the right of the first non-zero digit. Next, is count the number of places to the right of the decimal point. Let's count the number of places. 1, 2, 3, 4, 5, 6, 7. Last is write the number in the form of 8 times 10 raised to n after dropping all zeros to the right of the last non-zero digit. And our answer is 5.4 times 10 raised to 7. Take note, grade 7, if the movement of the decimal point is going to the right, the exponent is positive. Example number 2. Write 0.000028 to scientific notation. First, place the decimal point to the right of the first non-zero digit. Next, is count the number of places to the left of the decimal. Let's count the number of places. 1, 2, 3, 4, 5, and 6. And last, you're going to write the number in the form of 8 times 10 raised to n after dropping all zeros to the left of the last non-zero digit. And the answer is 2.8 times 10 raised to negative 6. Take note, if the movement of the decimal point is going to the left, the exponent is positive. Let's have example number 3. Neptune is about 4,460,000,000 kilometers from the Sun. Let's write this number in scientific notation. First, you're going to place the decimal point to the right of the first non-zero digit. Next, is count the number of places to the right of the decimal. Let's count 1, 2, 3, 4, 5, 6, 7, 8, and 9. Last is you're going to write the number in a form of 8 times 10 raised to n after dropping all zeros to the right of the last non-zero digit. And our answer is 4.46 times 10 raised to 9. How about writing scientific notation to standard or decimal notation? Let's have an example. Example number 1. Write 2.16 times 10 raised to 4 to standard notation. First is write the first part of the scientific notation, and that is 2.16. Next is count 4 places from the decimal point to the right. Since the value of n is 4, and take note, if the value of n is positive, the movement of the decimal point is going to right. Let's count. 1, 2, 3, 4. Last is replace empty spaces with zeros. And 2.16 times 10 raised to 4 in standard or decimal notation is 21,600. Example number 2. Write 9.2 times 10 raised to negative 8 to standard notation. First, write the first part of the scientific notation. And that is
9 and 2/10.
next is count 8 places from the decimal point to the left since the value of n is negative 8. And take note, if the value of n is negative, the movement of the decimal point is going to left.
Count the number of the movement of the decimal point.
1, 2, 3, 4, 5, 6, 7, and 8. Last is replace empty spaces with zeros. And 9.2 times 10 raised to negative 8 in decimal or standard notation is 0.000000092 or 92 billions. Let's have our last example. A television signal travels 1 mile in 5.4 times 10 raised to negative 6
seconds.
Write this number in standard notation. Write the first part of the scientific notation, and that is 5.4. Count 6 places from the decimal point to the left since the value of n is negative 6.
1,
2, 3, 4, 5, and 6. Replace empty spaces with zeros. And 5.4 times 10 raised to negative 6 in standard or decimal notation is 0.0000054, or that is 54 million seconds. This time, let us try if you already know how to express numbers from scientific notation to standard notation and vice versa. All you have to do is click wow or haha emoji. For given number 1, express 3.1416 times 10 raised to negative 5 in standard notation. Is it wow? 314,160 or haha 0.000031416 or 31,416 billions. Your 5 seconds starts now. Time's up. If your choice is haha, you are right. Given number 2, if 520 million is in standard notation, which of the following denotes its scientific notation? It is wow, 5.2 times 10 raised to 8, or haha, 5.2 times 10 raised to negative 8. Timer starts now. Time's up. If your choice is haha, very good. You are correct. In given number 3, the diameter of a hydrogen atom is 0.000001 centimeter. Express the diameter in scientific notation. Is it wow? 1 times 10 raised to 6? Or haha, 1 times 10 raised to negative 6. Your timer starts now. Time's up. If your choice is haha, then you are correct. Good job, grade 7 students. You already know how to write scientific notation to standard notation and vice versa. Scientific notation and standard notation are classified as real number. But what is a real number? Real number are any of the numbers from the preceding subsets and can be found on the real number line, including rational and irrational numbers. Examples: negative 10, 1/2, 0.6 repeating, 1.5 times 10 raised to 2, square root of 2, 290,000, 3.5, square root of 4, and 0.12472 non-terminating and non-repeating decimal. Under real numbers, we also have rational and irrational numbers. Rational numbers, these are the numbers that are integers and can be expressed in the form of a over b, or fraction, where a and b are integers and b is not equal to 0. While irrational numbers are those numbers cannot be expressed in the form of a over b or fraction, where a and b are integers and b is not equal to 0. Based on the given examples of real numbers, let's take a look at the numbers belonging to rational and irrational. Negative 10 is a rational since we can express this as a simple fraction as negative 10 over 1. 1/2, that is a rational. Pi is an irrational since the value of pi is 3.1416 non-terminating decimal. 0.6 repeating decimals is irrational, that is equivalent to 2 over 3. Square root of 2 is an irrational since it is non-repeating and non-terminating decimal. 1.5 times 10 raised to 2 is a rational number and can be written as 1,500. 3.5 is also an irrational number and can be expressed as 7 over 2 as fraction. Square root of 4 is a rational and that is 2. And lastly, 0.12472 followed by a 3 dots, it means that is non-repeating and non-terminating decimal. Rational numbers has a subset. These are integers, means this is a union of the set of whole numbers and the negative and counting numbers. Examples, negative 1, negative 16, 8, and negative 12. Integers as well can be a negative and a whole number. Example for negative numbers, negative 1, negative 4, and negative 7. For whole numbers, we have 1, 2, 3, and so on and so forth. While a whole number, these are 0, composed of 0 and counting numbers. If we have integers, we also have non-integer. These are the fraction, are parts of a whole. Examples, 1/2, 2/3, and 7 over 9. And decimal are numbers whose denominator are power of 10 or its multipliers. We have two types of decimal under rational numbers. These are the non-terminating but repeating decimals, and we also have terminating decimals. Examples, 0.55 repeating and 0.12 repeating. For terminating decimals, we have 0.12, 1.23, and 3.9. For your better understanding, let's have our activity number 3, entitled Stop and Go. All you have to do is to write go if the given statement is true and stop if it is false. Write your answers in the comment section below. Okay, let's do this. Given number 1, all integers are rational numbers. Is it go or stop? Comment your answer now. If your answer is go, very good. You are right. Statement number 2. Any rational number is equal to a terminating decimal. Is it go or stop? If your comment is stop, then great, you got a correct answer. For statement number 3, 4.25 times 10 raised to 7 is a real number. Is it go or stop? Comment now. If your answer is go, great job. Yes, 4.25 times 10 raised to 7 is a real number. Statement number 4, 3 over 4 is a non-integer. Is it go or stop? Go to the comment box and type your answer now. The answer is go. 3 over 4 is a non-integer. Very good, grade 7. For the last statement, 12.125 is an irrational number. Is it go or stop? Comment now. The correct answer is stop. 12.125 is a rational number. Real numbers can be represented in a number line. And what do we mean by a number line? A number line is a straight line extended on both directions, as illustrated by arrowheads and used to represent the set of real numbers. On the real number line, there is a point for every real number and a real number for every point. In arranging and plotting real numbers on the number line, consider the following guide questions. How to arrange the sets of real numbers? In ascending order or descending order? Ascending means arranging numbers from least to greatest value, while descending order means arranging numbers from greatest to least value. How about opposite numbers? Opposite numbers are numbers that, when placed on a number line, are the exact same distance away from the zero, but on opposite sides or in opposite directions. Example, if the given number is 5, that is 5 units to the right of 0, then the opposite is negative 5. That is 5 units to the left of 0. If the number is positive 2, that is 2 units to the right of 0, the opposite is negative 2. That is 2 units to the left of 0. Next question is, where is the location of the numbers? Using 0 as our reference point on the number line, if the given is positive, that is located to the right of 0. While if it is negative, then it is located on the left of 0. Let us plot now and arrange the real numbers in a number line. The given are square root of 4, 0.5, negative 3, 4 over 3, 3.168, and negative 1/2. Then follow the steps in plotting a real numbers in a number line. First, we're going to express all numbers in decimal. Square root of 4, that is 2. 0.5, still that is 0.5. Negative 3, same. 4 over 3, that is 1.33. Repeating decimal. 1.68 is already in decimal. And negative 1/2, that is negative 0.5. And next, locate all numbers in a number line. 2, 0.5, that is between 0 and 1. Negative 3, that is 3 units to the left of 0. Next is 1.33. Next is 3.168. And the last is 0.5. Now, arranging real numbers on the number line. Square root of 4, same given. We have 0.5, negative 3, 4 over 3, 3.168, and negative 1 half. Let us arrange now. Descending order. That is from right to left. Started at 3.168. Square root of 4, 4 over 3, 0.5, negative 1 half, and negative 3. In ascending order, that is from left to right. Starting at negative 3, negative 1 half, 0.5, 4 over 3, square root of 4, and 3.168. Let's have activity number 4. Arrange the syllables of a word in descending order to reveal the longest name in the Bible. For her, we have square root of 16. For Bas, we have negative 15 over 2. For Hash, that is negative 3.6. Ma, 5.9. Lal, that is 1 times 10 raised to negative 2. For Sha, we have 9 over 5. You are given 30 seconds to answer. Your timer starts now. Time's up. Let us reveal our answer, or let's answer this. Square root of 16 is equivalent to 4. Then plot this in a number line. Next is Bas, that is negative 15 over 2. And that is equivalent to negative 7.5. Next is Hash, that is negative 3.6. Next is Ma, that is 5.9. Next is Sha, that is 9 over 5, equivalent to 1.8. And last is Lal, that is 1 times 10 raised to negative 2. And to reveal the answer, the longest name in the Bible is Maher-shalal Hashbaz. To sum up our discussion today, scientific notation, this is a convenient way to write very large number or very small numbers, and written in the form of a times 10 raised to n, where a is a decimal number greater than or equal to 1 but less than 10, and n is an integer. To change standard notation to scientific notation, first is place the decimal point to the right of the first non-zero digit. Next is count the numbers of places and write the number in the form of a times 10 raised to n after dropping all the zeros to the right of the last non-zero digit. To change scientific notation to standard notation, write the first part of scientific notation, count the places from decimal point to right if it is positive and to the left if it is negative, and replace empty spaces with zeros. For real numbers, these are the numbers from the preceding subsets and can be found on the real number line, including rational and irrational numbers. We discussed about rational numbers and irrational numbers. Rational are numbers that are integers and can be expressed in the form of a over b or fraction, where a and b are integers and b is not equal to 0. While irrational numbers are those numbers that cannot be expressed in the form of a over b or fraction, where a and b are integers and b is not equal to 0. Under rational numbers, we have integers, fraction, and decimal. Integers, this is the union of set of whole numbers and the negative and counting numbers. Under integers, we have negative and whole numbers. Under whole numbers, we have zero and counting or natural numbers. For fraction are part of a whole, and decimal are the numbers whose denominator are power of 10 or its multipliers rather. And decimal, we have two types, the non-terminating and repeating decimals and terminating decimals. Under irrational numbers, we have non-repeating and non-terminating decimals. In arranging and plotting numbers on the number line, we have to express all numbers in decimal and and we're going to find the location of the numbers. And lastly, we're going to determine if it is ascending or descending order. It's time for our Q&A. If you have question, you can type your question at the comment section below. You are given 30 seconds to type your question now. Okay, so we have two questions here. The first one, what is the most important rule in scientific notation? The following rule can be convert number into scientific notation. The exponent or the value of n in scientific notation is equal to the number of times the decimal point must be moved to produce a number between 1 and 10. For second question, how will you make ordering real numbers easier? First, convert all the numbers to decimal, then plot those decimal on the number line and compare them. Okay, grade 7, if you have questions or clarification, you may ask your teacher during follow-up discussion. To test if you fully understand the lesson, answer these activities. Congratulations! You did a great job. I'm very much confident that you have developed the most important skills today in writing real numbers in scientific notation, describing the different subsets of real numbers, and arranging real numbers in increasing and decreasing order on the number line. That's all for today. See you again in the next Valenzuela Live. This is Ma'am Eliakim Dugos from Valenzuela National High School, giving you with a quote from Will Durant, "In my youth, I stressed freedom. In my old age, I stress order. I have made the great discovery that liberty is a product of order." Bye!